Hi, I'm Connie Sultan. You may know me from my greatest hits, Let's Avoid Creating That Technical Debt, and Where Are Your Tests? Today we're going to be discussing a topic that I get asked about practically every time I do a site visit: unit testing. What is it? Do I have time to unit test? Can I run unit tests on my traditional Synergy code? In this crash course on unit testing, you're going to learn why the practice is such a critical piece of test-driven development, exactly how it adds value to the development process, and what you need to run unit tests on your traditional Synergy code from within Visual Studio. In order to use the new traditional Synergy unit testing project template in Visual Studio, make sure you have the following tools to work with: Visual Studio, preferably 2019, SDI, which is our Synergy extension for Visual Studio, and SDE, version 11.11e or above. So let's get straight to it. Unit testing describes the process of testing one small piece of code one at a time to make sure it behaves as expected. We're not talking about complex operations here. Think individual subroutines, functions, and methods. Now, if you're thinking, that sounds excessive, time-consuming, and not nearly as engaging as actual coding, don't worry, you're not the first person to feel this way. Here's what I remind folks during my consulting engagements. Catching a bug early is always better than finding it later. If you, as the developer, discover an issue in a unit test, you can resolve the problem right then and there, before it affects someone else's code. Unit testing also comes in handy if you're not a huge fan of documentation, as each test describes exactly how a unit is supposed to function. Create high-quality unit tests, and your teammates will automatically have something to reference when it comes time to integrate your code with theirs. The positive impact that unit testing can have on your code becomes very apparent when you use it within a test-driven development process. For those of you who are unfamiliar with test-driven development, it's a programming paradigm that represents a notable departure from what we think of as the typical development cycle. Rather than coding first and testing later, the developer writes a unit test describing the functionality of a specific piece of the program. The test fails because that piece doesn't exist yet. Then, the developer writes just enough code to make the test pass. Finally, the developer cleans up the code and the whole cycle starts all over again. As you can probably imagine, this style of programming forces you to think more carefully about what you're trying to accomplish, thereby reducing defective and redundant code. This may represent more of a time investment earlier on, but higher quality code means less development and debugging required during the final phases of a project's lifecycle. Elevator pitch aside, unit tests do take concentration and effort. To make this process easier and more accessible to Synergy developers, we've added support for traditional Synergy unit testing in SDI, our Synergy DBL integration for Visual Studio. If you're a traditional Synergy developer interested in unit testing, you now have the following features at your disposal when you upgrade to version 11.11e: the traditional test framework, integration with Visual Studio, and the ability to run your tests from the command line. If you're interested in learning more about test-driven development and unit testing in general, I'll have some links up at the end. But for now, let's jump into some code. To start, I'm going to open up Visual Studio 2019. Just as a side note, yes, technically you can work with the traditional test framework in Visual Studio 2017, but it's not the optimal experience that you get with 2019, so just keep that in mind. Let's say I'm working in a test-driven development environment. I want to create a new method, so the first thing I'll do is stub the method for use with the unit test. We'll get into stubbing in a second, but to start, I'm going to create a new solution and call it MathApp. Next, I'll add our division project, which will contain our division subroutine. Here's where stubbing comes into play. Rather than writing my div subroutine right now, we're going to have the subroutine return something simpler, just the exception we want to see thrown when it's called by the unit test and the test fails. Seems a little counterintuitive, but this is useful for several reasons. For starters, you don't have to worry about passing actual data. You're also getting a consistent result every time. Not to mention, starting with a failing test serves to verify that you can detect defects. Now that we have our stubbed subroutine, it's time to write the unit test. I'm going to create a new project. In the Search for Templates field, I'll look up Unit Test and select the Unit Test Traditional template. My Test Explorer window isn't visible yet, so I'll open that up and pin it to the left. Finally, before I do anything else, I'm going to add a reference to my division project. The project template comes with a default test item that references the test framework. Let's take a look at what's going on here. We have Unit Test 1 as our test class. The test class contains all our test methods and properties. Within that test class is the default test method, aptly named test method. For the purpose of this video, we won't get much more complicated than this, but for future reference, our documentation site lists all the attributes supported in traditional Synergy unit testing. Here's the owner attribute. This could come in handy if I want to sort test results by owner in Visual Studio's Test Explorer, so I'm going to add that to my test method. You'll notice that I'm enclosing owner in curly brackets. That's required for your unit test attributes. Now, I'll add the data that our subroutine is going to be tested against. And here's where another piece of the test framework comes into play. To see if the results of my div subroutine match the test data, I'm going to use an assert statement. The synergex.testFramework.assert class includes methods to use when testing different conditions in your unit tests. I'm using the r=equal method. Heading back to the documentation again, there are a few combinations of parameters that I could add to r=. I'm adding the expected number, or the number the test expects, and the actual number, which is what my div subroutine will return. If you've been paying close attention, you'll know that the expected value and the actual value will not wind up as equal. The only way to know for sure is to test. Let's see what happens when we build. The build was successful, and now I can see the test in the Test Explorer. Now, when I run my unit test, it fails. And Visual Studio makes it very clear that the test has failed with these little red X marks. Passing tests would indicate a false positive, since I haven't implemented the subroutine yet. Now we're in the second phase of test-driven development, implementation. I'm going to go back into Division and update my div subroutine with the aim of having it pass the unit test. I'll run the test again, and this time it passes. That's exactly what I'm hoping will happen. Again, this is a single, very simple test for the purpose of this demonstration. Once you start running multiple tests at once, I would recommend checking out Microsoft's documentation on unit testing in Visual Studio, as they have tips on how to filter tests, run specific tests, basically how to customize your test settings for your unique situation. In addition to the documentation that Microsoft have put together, I recommend checking out our documentation at synergex.com. There's more detail in there about other assert class methods, as well as general guidance for traditional Synergy in Visual Studio. Finally, it's important to note that unit testing will tell you a lot about your source code, but not everything. You'll need to conduct separate tests to learn about application performance, integration, security, and other functional and non-functional aspects of your code. That's it for this episode of Connie's Corner. I'll see you next time.